Greetings. Let's move on to our next big topic in chemistry, water. We're going to look at why water is molecularly different, why hydrogen bonds are so common in water, why that might be important, what properties of water are so important to life, and why water is key to homeostasis. I'm going to move me over here. So, uh, why is water so critical to life? Water is different than lots of other molecules that are common, and we can get into some of the discussions about other molecules, and we kind of will touch on those later. But let's focus on water for a second and touch back on something we focused on in the last video, and that is that water has lots of hydrogen bonds in it. Why is that important? If you look at a drop of water as we have here, we've zoomed in and zoomed in and zoomed in really detail, we can actually begin to get an idea of why water is different. If you have, we'll take this molecule here. Remember, we have H2O. This is the oxygen, of course, and we have this is hydrogen, and we have a hydrogen down here. And recall that hydrogen and oxygen are different in terms of their electronegativity. Oxygen is one of the most electronegative atoms, which means it's really good at what? Pulling on electrons. So if we imagine that we have electrons that are being pulled, even though they're being shared in the covalent bond between oxygen and hydrogen, the sharing is not equal. So oxygen is pulling electrons close to it from this hydrogen as well as from this one. And so we end up with oxygen having electrons close to it, which means oxygen takes on a slightly negative charge. It means the hydrogens, because we pulled pulled electrons away from them, they take on a slightly positive charge. So the result is we have essentially a little magnetized way of thinking of it, a little magnetized or charged molecule here with positive pieces and negative pieces. If I have this water molecule with a positive, slightly positive piece and a positive piece and a negative piece around other water molecules that also are exactly the same, then what am I going to get here in terms of this bond, this connection? This is going to be a hydrogen bond. So hydrogen, because it's positive, is going to be attracted to the oxygen negative here. And because of that, I'm going to get a hydrogen bond. And 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 as you can tell, with all of the oxygens and all the hydrogens having slight charges, and all of these water molecules attracted to one another, water becomes somewhat molecularly sticky. Seems like a sort of a funny way of thinking about it because we don't think about water being sticky. And I'm not saying it's sticky like sugar. I'm saying it's sticky because the molecules are attracted to one another. And that's going to ultimately give water some different properties. Here are some of them. Water has very good heat storage. That is, water does not change temperature too readily because of all those hydrogen bonds. We won't delve into this conversation too deeply, but if you think about what heat is, it's molecular movement. How much molecular movement is going to occur in water with all of those water molecules sort of stuck together? Not a lot. That is, water requires a lot of heat before it's going to break those bonds. So water doesn't change temperature too much. That's actually good for reasons we'll touch on in a minute. But notice hydrogen bonds are the reason for that property. Water forms ice. We won't delve into that too much. That's more of a discussion for ecology. But for example, if you look at a frozen pond in the winter, the ice is on top. It's not at the bottom. Most things, when they get really, really cold, they get really, really dense and sink. Water floats because it has a high number of hydrogen bonds that affect its structure. Water has a high heat of vaporization. This is similar to heat storage, but once again, water is very difficult to make it change states. You've experienced this if you've been trying to cook some or make some tea on the stove, trying to boil some water. it takes a little while and a lot of heat before water is going to change from a liquid and to become vaporized into steam. And that's because there's so many hydrogen bonds holding so many water molecules together. It takes a lot of energy to break those down and water to be released as steam. So we'll discuss in just a second why that's useful for life. Water is very cohesive, as you've already seen. Hydrogen bonds, once again, are going to hold water molecules together and give water sort of this molecular sticky property. I'll show you a slide of that in a second. And water is highly polar. As you can imagine, with positive and negative bits for every single water molecule, water is polar. And think about why that might be important. If water is polar, it's going to be attracted to ions and other polar compounds. So if you put salt, NaCl, which we know is ionic, it's a positive sodium and a negative chlorine. If you put those in water, salt is going to be broken down because water is going to be attracted. In that case, I'll sketch this for you quickly. If I have NaCl and I have ultimately Na plus and Cl minus, if you think about a water molecule, the sodium, the positive part, is going to be attracted to the oxygen of water. The chlorine is going to be attracted to the hydrogen of water because, again, this is going to be slightly negative and this is going to be slightly positive. But you can see if I were to put salt into water, it's going to be pulled apart because of water's properties. So water has high heat storage, forms ice, high heat of vaporization. It's very cohesive in high polarity, but please see why all of these things are true. Because of water's molecular properties, how it's made up. It's a very polar molecule that sticks together. So here's sort of a cool picture of how water is cohesive. The picture was taken at just the right second to where you see water forms kind of this sheet or band of how all the water is sort of sticking together. Just a cool picture. Finally, why is water needed by our bodies? If we think about then water's properties, why do we need it so much? Well, water is needed for chemical and metabolic reactions. Our chemical reactions occur in water. Water is also referred to as a transport medium or universal solvent. As we've just seen with salt, lots of things dissolve in water, so lots of things can be carried by water. Your blood is primarily water. Water assists in the removal of wastes. We know, of course, with urine formation that water is needed to carry away those products that we have to get rid of. One that we've touched on a couple slides back, water is important for temperature regulation. Think about this, that you are about 2/3 water. You don't change temperature very quickly. You can go outside on a very cold day and you don't instantly get cold. You don't go outside on a hot day and instantly your temperature doesn't increase 20 degrees because of the temperature outside. Water is slow to heat up, slow to cool down, and that's why water is a very stabilizing force for our temperature. Water also cushions and protects us from physical trauma. Since we have a lot of water in our tissues, your muscles, for example, are 50% water. Water sort of absorbs blows and keeps us from experiencing too much trauma to our tissues. So, in short, water is critical to homeostasis. Without water, we could not carry out our chemical reactions, nor could we even exist. Can you name one living thing that doesn't need water? Nope. Everything requires water.